Okay, welcome back to our next lesson on inverses. The last video kind of cut out a little bit quick, so I'm going to finish up what we were discussing there first. Remember, we were looking at something called the horizontal line test, and it will tell us, the horizontal line test, if a function has an inverse or not. So this is on page 24 of your notes. We looked at example 3a previously, and we saw that this parabola, which is a function, of course, because it passes the vertical line test, uh, unfortunately, it does not have an inverse because it fails the horizontal line test. All right. So 3b is what we were kind of doing when the last video cut out. Again, I can clearly see this as a function because this graph passes the vertical line test, but I notice it also passes the horizontal line test. So because of that, I mean, think about a horizontal line being drawn anywhere at all on this graph, and it will only intersect the graph in one point, no matter where you put your horizontal line. So what we can say is that this function does have an inverse. All right. Because if you're asked for a justification, because it passes the horizontal line test, HLT. You can use that as an abbreviation for the horizontal line test, okay? So that's how you can tell clearly if a function, from its graph anyway, if a function has an inverse or not. All right. So let's move on now to the next page. This is page 25. And what we're going to look at today is if I were to give you a function, f of x, fairly simple function, what would you do to actually calculate the inverse? So we haven't done that quite yet. All right, so that's what we're going to start right now. The steps are shown right here. Okay, and I'm going to do it slightly differently than the steps explained, but it's basically the same technique. The first thing to do is to make sure to justify that it actually does have an inverse, and that would be through the use of the horizontal line test. All right. Then start with the given function. Take your function, and what you do is you replace f of x, which is the same as y. You replace the y's with x's, and you replace the x's, not with this function. I'm going to get you to do that after. Replace the x's with y's. Now, why in the world would you do that? Well, remember that when we looked at functions previously, we saw that the basic relationship between a function and its inverse is that the x's become y's and the y's become the x's. All right? And that's not true just for the numbers. That's true for the variables themselves. So let's look at an example right here. Now, I'll just do one of these examples. These are on page 25, as I said. All three of these are fairly straightforward linear functions, okay? They don't look very difficult. I'm going to do B with you, I think. A is really simple anyway. I mean, you should have no trouble with that once you see how B works. But now here's the steps that I want you to use, all right? It's a little bit different from the explanation. Notice that your function is g of x equals 3x plus 2. Now, clearly that does have an inverse because it's, first of all, linear. The slope is 3. It would, if you graphed it, pass the vertical line test, therefore being a function, and it would pass the horizontal line test as well, and therefore it does actually have an inverse. So here's the steps I want you to do. Step number one, if you see g of x there like that, or f of x, or any inverse, or any function notation, sorry, I want you to change that into a y, starting off. Now this is different from what some instructors teach, but you're going to end up with the same result. So call this y equals 3x plus 2. All right? Same thing. It means the same thing. Now, the next step is what I call the switch step. Now, remember what that means. The x's become y's, and the y's become x's. All right? So, change that y into an x equals, change that x into a y, and then you write plus 2. Now, believe it or not, that is the inverse. That really is the opposite function of what we started with. The only thing is, you have to write it looking like a function of x. So you have to get the y by itself. So if you do that, if you get the y by itself, you're going to have x minus 2 equals 3y. And you divide now both sides by 3. And of course, you could put the y, let me come up here. You can put the y now over on the left side. That's no problem. You don't have to worry about changing the signs. And you can leave it as x minus 2 over 3 if you like. That's your inverse. Or you could even break it up into two pieces. You could call that, for example, 1/3 x minus 2 over 3. Either way is fine. It doesn't really matter. Okay? Now, you're not quite finished yet, though. All right? That is your inverse. But remember, you have to express it using inverse notation. You're not quite finished yet. The original function was called g of x. So the final step, and this is a very important step, this is vital, change that y into g inverse of x. That's your function, your inverse function notation. And then you write equals x minus 2 over 3, and now you're finished. Now you're done. Okay? So that's how you calculate the inverse of a function. Now I'm going to look at example number 5 with you as well in just a moment. But before I do that, just turn to page 26. And here's some practice problems that I'm going to get you to try. Not right now, but on your own. 1a looks pretty straightforward. F of x equals 2x plus 3. B looks fairly straightforward. Remember to change the h of s into, well, you could call that y. And you can leave it as an s if you like. Remember that the inverse is going to be h inverse of s when you work that out. C looks okay. D looks okay. You can try those. All right, yeah, you can try those. E, if you change those x's into y's and y's into x's, you're going to have a really hard job getting the x by itself, or getting the y by itself when you change them. So I want you to make a slight change here. For E, eliminate the plus 5x. Just get rid of that. Just rub that out altogether. You just use the function g of x equals x squared minus 8. Now there's something else you have to do with that as well. All right, and you'll see now once I do number 5 on the previous page. Number 2, I'm also going to assign for you to do. That's easy. Now let's just go back and look at this one, number 5 on the previous page. Look at this very carefully. We've got a parabola, a nice blue parabola. Color doesn't matter. And it says below is the graph of the function f of x equals 2x squared plus 3. Okay, yes, it's a function. No question about that. It passes the vertical line test. But now look at what part A say. Does the function have an inverse? And that would indicate, or that would be indicated by the horizontal line test. Well, you can clearly see that if you draw a horizontal line anywhere, or most anywhere, through that parabola, it will intersect in two places. So the answer for part A is no. It does not have an inverse. And the reason, of course, is because it fails the horizontal line test. All right? But then there's a second part to this question. Under what conditions will the inverse exist? And if that's the case, then you go ahead and you find f inverse of x. Well, this graph, everybody, fails the horizontal line test. How could it have an inverse? Well, it can if you throw away part of your graph. This function right here, here's the vertex right at the bottom. If I were to throw away, say, the left-hand side of that, all right, in other words, not use those x values, not use those. And if I come down clearly, you can see, all right, the x value right there is 0, you see? So if I were to throw away the left side of that graph, then it would pass the horizontal line test. And that's called, and this is the answer to part B, is called restricting the domain. All right, we restrict the domain. And we can restrict it to, well, if I'm only keeping the right-hand side of the graph, that means I'm keeping from 0 and up. So look at that. Just keep the greater than or equal to 0 part. X is an element of the real numbers. Okay. Now, also, I'd like you to also write down what the range is. And you might be asking, well, why would I want to write down the range? Well, there's a reason for that. Watch this. Y such that. Now, if you look at the Y values, notice it's sort of the lowest it gets right there is a 3 and above. So that would be greater than or equal to 3. Y belongs to the real numbers. Now, there's a reason you wrote that down. Now come back and look at your function. And now let's calculate the inverse now. All right, so change the f of x into y is equal to 2x squared plus 3. Now what I want you to do is change. Here's your switch step. My goodness, I'm running out of time here. Change your switch step so the x's become y's and the y's become x's. Here you go. Look at that. See that? There. That's your inverse. But you have to get the y by itself, and then you have to change it into f inverse of x notation. So watch what you'd get. You'd have 2y squared plus 3 equals x. 2y squared plus 3 equals x. Bring your 3 over. That becomes x minus 3. Divide both sides by 2. You get y squared equals x minus 3 over 2. But now you have to take the square root of both sides, don't you? Right? So you're going to get y equals, and there's a big square root sign on the other side, yes, x minus 3 over 2. But remember, in front, there's a plus or minus. Uh-oh. That means that the inverse is not a function, because remember, plus or minus should not be there. Well, in fact, it's not there. Because come back up here. Let me just change my pen color for a second. Come back up here and look at the domain, the restricted domain of your original function. Remember that that becomes the range of your inverse. Remember, inverse of the domain of the function becomes the range of the inverse and vice versa. Well, if that's the case, then your range for the inverse is values of y such that y is greater than or equal to 0. Now, do you see what that does? Do you see what that does? That means that it can't be negative. It must be positive. So you can wipe out the plus or minus, and now it works. Okay? Now it's perfect. Now the inverse will also be a function, and everything is fine and dandy. Oh, by the way, the domain of your inverse is the same as the range of the function. So your domain will be, how much time do I have left? Oh, I've got over a minute, so I've probably got lots of time. The domain will be x such that x is greater than or equal to 3. X belongs to the real numbers. It's the same as the range of the inverse, you see? And that's true as well. That's obviously true because if x was less than 3, this would be negative. And we said you can't take the square root of a negative number. Not in this chapter, because we're only dealing with real numbers. So it's important to note that usually for parabolas, you will have to restrict the domain. Keep that in mind when you're doing part E right there. Look, because that's a parabola. That's a parabola. You're going to have to restrict the domain and show it just like we did up here. By the way, I'm not completely finished. I didn't change the y into g inverse of x, and that's an important step. You have to change that into g inverse of x equals the square root of x minus 3 over 2. All right? So I'm almost out of time. I'll stop there, and I'll get ready and make another video now on our next lesson. So I'll see you then. Bye-bye.